Today I'm building an RC plane from scratch. This video highlights the whole build process and the test, so be sure to stick around until the end. Anyways, let's get on with the video. To start out this build, I needed to put the electronics together. I'm using this 30 amp 3-phase ESC for the motor and a 7.4 volt LiPo battery. I knew this battery was going to be way too large for the final plane, so I'm just using this for testing. What I wanted to do first was test the motor and the propeller to see if they could produce enough thrust for this plane. This stock orange propeller ended up not producing enough thrust, so I had to 3D print my own propeller. I tested this propeller and it produced around 350 grams of thrust, which is just fine.
So that test, the scale read 350 grams, which is better, but not as much better as I wanted it to be. Okay, so I've been having problems trying to decide what battery I'm going to be using for the plane. I was originally testing with this battery, but it's so heavy it weighs as much as the entire plane should weigh when it's done. So that's out of the question. I was then thinking I can use 4 18650 cells. These weigh quite a bit too, so I'm not sure. I was then thinking I can use one of these RC car battery cells, which weigh not that much, only like 40 grams, and they can work, more like 50 grams, and they'll probably provide enough amperage. The only problem is I have two, and they're both dead. They're at like 4 volts, 3 volts. For a 7.4 volt battery, that's not good. I do want to try and see, since this one's at like 3.8, this one's at like 3 volts, maybe I want to try to take it apart and see if any of the cells are fine.
So I'm a 100% trained professional and you guys should not do this at home. This is for educational purposes.
In theory, each of these cells should be at 3.7 volts, or they're a 3.7 volt cell. They're probably going to be at like 1.5 because it's like half what it should be. Oh, how nice. It's at 0. Wonderful. If this one's at 0, that means the other one could be at 3 volts. And that means the other one's good. So I'm gonna have to check that. It is at 4.12 volts. So it's like 80%, 90% charged. So this cell is actually perfectly fine. This cell is dead. So if that's the same case for this, I can take the 2 good cells, combine them into 1 battery, and it should work. Now this should be a working battery. Keyword being should be, because I don't know if it actually works. It says it's charging, but when I tried it with the dead battery, it said it was charging for a few minutes and then just like shut off. So I'm gonna leave that for a few minutes. If this works, it'll be insanely easier to make this plane. We have motor, receiver, and ESC weighing in at 116 grams, which is not bad. I think it's not bad. That's what we're gonna use, so yeah. This motor produces around 300, 350 grams of thrust. So I'm gonna want the total plane weight to not be more than 350 grams. This battery, which I think it works, brings the weight up to 168. So around 170. That means the only other weight we need is the airframe, wings, everything, and servos for roll, pitch, maybe yaw. I'm probably gonna add yaw. But I think we can fit that in what? 130, 180 grams? In between there. This is kind of what the final thing will look like. It's a rough design. There's gonna be, we have big wings, thin wings. That's about 130 centimeters of wingspan, so fine for a glider. And we have this fuselage, just a square fuselage, motor up front. It's 4 centimeters wide, 75 centimeters long. We got a tail section. And these wings are actually tilted up at 5 degrees just to make it more stable. And I think I can make this airframe 150 grams. That's like the goal. Less would be ideal. But I'm printing some struts for inside the wing, and there's going to be carbon bar running through the wing to keep it stable. I only ordered a 480 millimeter one because that was the most they had. So it'll really only go from here to like around there and stay on the other side. And then I'm going to have a connector in the middle. But like, that's fine, right? That's fine.
Building the airframe now.
How nice is that? A square fuselage. This second part of the fuselage is looking pretty good. Now I want to weigh the entire fuselage. Both parts, no electronics, just the fuselage. We have 23 grams, which is pretty good for this kind of aircraft.
Okay, now I'm building the wings, and I'm using paper instead of foam because it's light.
So we have the first wing with paper on it. I decided since the paper isn't big enough, I'm using foam as the trailing edge. I don't know how much weight that's going to add, but it's probably going to be fine with the amount of weight we're saving with all this paper. In fact, speaking of weight, let's weigh this wing. So with our scale here, this wing weighs a total of 37 grams, which is not bad. With the second wing also weighing 40 grams, that's going to be 80 grams of wing. With the roughly 25 grams of fuselage plus 80 grams, that's going to be 105 grams. That would make everything 105 grams without the tail or the servos, which
Yeah, so unfortunately the rest did not get recorded, but here's a picture of the plane, and I'm going to go test it now.
There we go. The tail looks kind of small now, but it's very windy. This thing's gonna blow over. This thing is very light. Ooh, we have roll, pitch, somewhat. One more roll. Oh, come on. Okay, that battery's not plugged in yet.
The plane was having a problem. I thought it was because the battery wasn't plugged in all the way, but I'm pretty sure it was something else. Now you can watch me struggle to figure out what it is and then give up.
What do you mean? Let's build. Probably should have saw those. It's fine. This thing might turn off midair, but ooh, I don't like that right wing. Yeah. Okay, let's try this. Let's see if it even gets in the air. I want to see. It's not a bright sunny day. Yes. There's no steering. We're gonna go very slow. Oh, that's great. How fun. Oh, how very interesting. Here, I'll do this. Is that even enough thrust? Bro, it turned off again. Oh, is it not, bro? What? What are y'all doing, bro? Okay. No. What the fuck are we doing? Can you not? What is the problem here? Well. What? Why? I just won't turn on. Okay, I give up. Taking it back. I give up. I